So you should be able to see everything now again. Could someone here in the chat just confirm that it still works, to be sure for me? File size difference from the unpacked executable to the packed executable. It's Mimicuts normally has like 200 kilobytes less. It's about 1.3 megabytes, and this is 200 more. So it's not that big, the size difference. So now I'm going to tell something about the Packer usage, about its capabilities and what you can do with it and what you cannot do with it. So I'm again going into the Packer directory, and we also compiled it. We also have it in the current directory. And now again, we will take a short look. Oops. At the help. And then I'm going through each options and tell something about it and on how to use it. Yeah, basically the Packer encrypts portable executables, so C or C++ compiled binaries. It can encrypt assemblies, so C# written binaries, and it can also encrypt shellcode. And those are decrypted on runtime after doing some bypass methods, techniques, for example, patching AMSI or patching ETW. It's also this German and W. I think we is not correct. Yeah, you can for example sleep. It's not that it's calling the Windows API sleep, but it's calculating for a moment for the seconds that you specify. And just the basics. If you want to encrypt and load afterwards a C# binary, then you have to specify this parameter. You have to specify a C#. If you don't do so, it will not work. And we can again use the example seatbelt. If you don't want to add any other options, then you can, and for this, I will turn on Defender again because, yeah, it's just to show that this obviously bypasses it. So we again, this folder is in an exclusion. So seatbelt normally would have been flagged. It will not get flagged here. But the desktop and the Packer directory is not in the exclusion folder. So if it works in the current folder, then we're good. So we have to specify the file with the file parameter. Just forgot that myself. So in this case, to just encrypt seatbelt and to build a packed binary, it's just these two parameters. And then we have a new executable called loader.exe. No, that's the default file name. If you want to change that, you can also take a look at the size again. It's 636 kilobytes here, and seatbelt is normally 543, so it's not that much more. If we want to execute that, it works. It's not flagged. It's not in an excluded folder. We can also rename that, for example, to seatbelt exe. We can put this on the desktop. Oh, exe. Okay. I don't have. And if I specify group all, you see that it's also working and it's not flagged. It does its enumeration now and works perfectly fine. So the packer is more or less in the very first case there to avoid static signature-based detections on disk. So if you want to normally just place seatbelt into some directory, will get flagged. Now it's loaded from memory, and when it's loaded from memory, it's not, the signature for seatbelt is just not included in the pack binary anymore, so it cannot be flagged there. Because by default patching AMSI and ETW, other detections such as the anti-malware scan interface would normally block seatbelt. That is bypassed by patching AMSI via syscalls, and patching ETW is also done via syscalls. ETW can be used by antivirus vendors or EDR vendors to check if, for example, assemblies are loaded in another binary. You can see that if you use, for example, Process Hacker or Process Explorer, whatever, then you can go into the .NET section and you will see that the namespace of seatbelt, for example, is there. And if we patch ETW before, it's not possible to see this anymore because there are no more events generated that contain this information. By default, AMSI and event tracing for Windows is used. If you don't want to use this if you know, for example, if you load shellcode, it's not necessary to patch AMSI because AMSI cannot detect shellcode. AMSI can only detect scripting languages, for example, VBS or PowerShell or C#, whatever, when it's loaded into memory, but AMSI cannot detect shellcode, therefore it's just not needed to patch AMSI to execute shellcode unless you did generate this shellcode with, for example, Donut. If you did so, then and if you have a C# binary assembly, for example, and if you generate shellcode via Donut, then you still have to patch AMSI to load this. But Donut does this by itself also. Yeah, if you don't want to use event tracing for Windows patch or AMSI patch, then you can say use these parameters. It's less signatures, it's less code. It may be that some EDR or antivirus vendor flags, especially the behavior for patching AMSI or event tracing for Windows. So if you have a solution that flags this, or if you just don't need it, you can specify those parameters, and then it will not be done anymore, so it's not included. Just to show you that this also works, we can see in the output here normally you see in the output that AMSI is patched or not. In this case, if I want to load it, you will see we get an exception, unable to invoke specified member load. That's assembly load. Assembly load is used in the very end to load the C# assembly, and this is an error message that more or less just tells us that AMSI flagged the binary because we did not patch AMSI, seatbelt was flagged and it cannot be executed anymore. So by default, patching AMSI and event tracing for Windows is enabled. As an alternative, if you want to encrypt or pack shellcode, for example, you can either specify this parameter, but you don't need it because it's default. By default, it's set to true. So by default, you can pack shellcode with it. And in this case, I just generated calculator shellcode with MSF Denim, 64-bit. So it's just spawning a calculator, this shellcode here in the folder. And if you want to pack this, you can do it with just the parameter file. Then the loader exe contains the shellcode, decrypts it on runtime, and executes it afterwards, also via syscalls. And as we can see, the MSF shellcode is also not flagged here by Defender. It just did execute fine. We had no detection, and yeah, that's also working. Okay, third thing, it was shellcode, it was assemblies, or you can use portable executables. If you want to use a portable executable, for example, Mimikatz. Whoop, didn't I put it in this directory? Looks like I didn't put it in this directory. It's here. Then you have to specify that you want to load a PE. And you have two options. Either you can use PE load that uses reflective PE injection or run PE technique in the very end to load the executable from memory. This is one option. And also, if you're using Mimikatz and if you're using the release binary from the repository, then this will not accept arguments. I don't know why. It's something Benjamin did something with this release binaries, which is different. I cannot tell what exactly this is, but you have to compile Mimikatz by yourself and to build a fresh version to make this work with parameters. That just for your information. And this is a release binary, so I think you will also see this now. The loader exe, unwanted app. Let's see if this is, what is the unwanted app? Oh, okay. Potentially unwanted behavior, but it didn't block, it is low. Never saw this one before, interesting. But it seems like yeah, somehow Defender detected it, but it doesn't block it. So Mimikatz is loaded now, and it's not possible to specify arguments here, and that's because it has something to do with the encoding. Everything you put here has some wrong encoding, and therefore it's not detected correctly as a command, which should be able. I think it is able. Yeah, you can specify arguments as parameters for the executable itself. And then they are also used. But if you do that in the binary itself, it doesn't work. If you compile it by yourself, it will work. Defender definitely gets smarter day by day. That's true. But if we, for example, we can do one test here. Maybe it did detect the syscall usage. I'm not sure, but we can change this syscall usage, for example, to, by default, the packer uses get syscall stop in the very end, so it's taking a fresh NTDLL from disk, putting this into memory, and it's extracting the syscalls from there. And if you use syswhispers, for example, it will use syswhispers version 3 from classvirus, and that will maybe bypass this detection. Maybe it's due to get syscall stop. We will see. Maybe Defender did detect that NTDLL was loaded from disk, and with this syswhispers, the syscall stops are included in the binary itself, so that it's not needed to load them from NTDLL on runtime. Let's see if we still get a detection. Oh, we even got it was even blocked. So syswhispers 3 seems to be blocked now. I think it was just yesterday or the day before that someone wrote in the Discord that he was able to bypass Mimikatz detection with syswhispers. But it seems to, in this case, with syswhispers, it seems to detect it. Let's try another one. But I would always, if you want to use Mimikatz, I can always recommend you to build a custom one. I did write blog posts about that. I did release a script on which automatically changes many things in the source code so that you can build your own Mimikatz version. If you do that, and if you pack the obfuscated Mimikatz version, it's very less likely that it will get detected. So in the most cases, the detection is not for the method, so not for syswhispers in this case, for example, but instead it's, for example, a memory scan. And if Defender just scans every new process, and if it just scans the memory, then it will see Mimikatz in clear text, and it can detect it, and it can flag it. And I cannot avoid this detection with the packer, as I could add additional features, and that's also planned to encrypt memory, for example. But that will only work for C2 stages, and it will not work for Mimikatz, for example. Because Mimikatz, if you encrypt the memory, then Mimikatz cannot be used anymore. So in this case, you have to indeed obfuscate Mimikatz by yourself to avoid memory scans, for example. We have a third option. We have Hellsgate. Let's check if Hellsgate is detected. So that's also the 3 methods that you can choose at the moment to use syscalls. It's either by default get syscall stop, or you can use syswhispers, or you can use as third option Hellsgate. So it looks like Hellsgate is not detected by Defender at the moment. We got a detection with syswhispers. We got a low warning with get syscall stop, and Hellsgate is not detected. So it has something to do with how the syscalls are retrieved in this case, at least for Defender. So I did tell you about on how to use Hellsgate, on how to use syswhispers. If you use just syswhispers without minus jump, then it will just embed the step, the syscall stops in the binary. If you additionally use jump, then other techniques will get included. For example, the syscalls will be obfuscated so that it looks, at least for the endpoint solution, that the syscalls come from NTDLL, and it's some random syscalls that can be detected there. So if I use, for example, nt create thread x, then the AV or EDR will maybe see some other function from NTDLL being called, but it will not see that it's nt create thread x. And there are, if you want to know what's exactly behind it, I can recommend you to just read the blog post about it. I hope it's linked here. Is it linked? Is it not linked? This is the blog post. But it also looks like I have to maybe do some further tests with this one. I don't know why this was detected. We can also try, maybe it's just the combination of this whispers and Mimikatz. Maybe that just triggered a memory scan somehow, and Mimikatz was detected. We can verify that by, for example, packing our calculator shellcode. Oh, it's not a PE file. Yeah, that's correct. If I specify PE load and I'm not giving PE but shellcode, it's obviously not working. So we didn't get any detection here. So I don't think that this whispers in general is blocked or detected. But instead it was a combination of the behavior lead to a memory scan, and the memory scan did detect Mimikatz, and therefore it was blocked. It was not this whispers itself getting detected here, because the MSF shellcode seems to be not flagged by a memory scan, or the process did end and the memory scan was not able to just take a look at the memory because the process was already already ended. So we have these two options: assemblies, PEs, or shellcode. And for shellcode, we have the options get syscall stub. We have Hellsgate, and we have syswhispers. So if you ever specify shellcode, you can choose between the default, namely no parameter, or Hellsgate, or syswhispers. And then I added many more different options. For example, you can just use a custom key to encrypt your binary. By default, the key is I won't tell it now, it's in the source code, but if I tell it, this video will get public. So vendors could try to detect this key. You can specify a default key. You can specify a custom output file name. We can do this, for example. We can say we want to encrypt or pack a calculator, and we want to use the key ultra packed out file or output. It's output, and output is ultra.exe. Then it will just use another key for encryption and decryption, and it will use another output name, namely in this case ultra.exe. And if you just want to execute ultra-exe here now, it will get decrypted with the key ultra-packed, and the shellcode is executed. That's these two options. You can also generate an DLL instead of an executable, and specify custom export functions for them. That's cool. For example, if you want to pack some C# binaries to execute them somewhere, maybe DLLs are not detected, but an executable is detected, or maybe you want to cool. Hi, ASCII hex. Maybe you want to avoid some things like app blocker. If app blocker is in place on some system, you can still execute DLLs with run DLL 32, for example, but you cannot execute executables anymore, at least with the default app blocker settings. If you want to generate an DLL instead, then you can specify the parameter DLL and DLL export function. You can specify some function name for your DLL. For example, I'm going to use test now as function name. The default file name here will be loaded DLL, and we can execute that. I think the function was test, right? It was test. So we can execute that via run DLL 32, loader DLL, and test. And if we want to pass, I will first do that just to check if it works. Seems to not work. Either this is a bug, or I did something wrong, or it was a detection, but I did test that before. Need to take a look at the... One moment. Maybe I did something wrong myself. Just try that again with just DLL. Missing entry nim main. This would be the alternative to execute an DLL. It seems to also not work. That's strange. I did use that and test that on another system, not on this one before. But maybe I have to take a look on this afterwards. But it can normally this can be used just with the parameter DLL, and DLL is generated. The normal function for Nim binaries. I don't want to take a look at the source code now, obviously, because it's not public. So I don't want to take a look on what may be wrong here now at the moment. Yeah, normally it's not DLL main, but it's Nim main, the default function. But somehow file DLL. I know what I did wrong. That's exactly what people told me from time to time. They forgot to mention what they want to do. I forgot to specify C# parameter here. If I don't set this parameter, this here will be threaded as shellcode, and it will execute it like shellcode, and that obviously doesn't work. So we need, if we want to execute an assembly, we need C#. And then this should work. Maybe I should later on add some checks on the target file to check if it's really an assembly, a shellcode, or shellcode is harder, but it's definitely possible to check for an assembly or to check for an PE from the magic bytes. Yeah, and this works. So I found the error here. So then you can execute the DLL and use the function, and that will result in your assembly being executed. The cool thing here is normally DLLs don't give you any output, but I did add some code for C# that you still see the output, and that's cool because you can use the DLLs like a normal executable. You can see the output, you can do enumeration, you can do whatever you want, and you will always see what's happening in the background. If you want to use parameters, you can just pass them behind, and as you saw before, seatbelt will get executed normally with, in this case, all checks. Yeah, that's the DLL output. We can also verify this for shellcode, for example. We use calc again. We specify DLL, and we don't change the export function in this case. And I think this should, maybe, I did not test it already, but this could also be used for DLL side loading already. If you know the functions for your DLL, you can specify them. Most likely it will not work if the functions don't accept the correct parameters. So for DLL side loading, most likely I have to add more things. So that should not be possible at the moment, just by thinking about it. So Nim main is the default function. So if we want to execute our calculator shellcode now, this works. We don't have output here, we don't need output here, and the shellcode is executed. Okay, that's about, and you can also use this binary here to execute the DLL as alternative. Okay, that's wrong. I'm not specifying a function here, but you can just, without any function name, use this, and the shellcode will also get executed. Okay, what else can I say? There are many more functions. This parameter here is just an alternative for syscall patching ETV. It's using Adam Chester's technique of setting the com plus ETV enabled variable to 0. If that's done, no more event tracing for Windows events are generated. So this also bypasses event tracing for Windows, but some solutions flag this behavior. They just flag setting this environment variable to 0. So it just depends on where you are. If you have, for example, some solution that blocks patching event tracing for Windows, but it doesn't block this here, then you can use this as an alternative. Okay. No args is just for if you want to pack an assembly like seatbelt. It makes no sense for seatbelt, but if you want to pack an assembly which is, for example, a C2 stager and that doesn't take any arguments or doesn't need any arguments, then you can specify no arguments. And then even assemblies which don't accept any arguments can be packed. Sleep. I think this is obvious somehow. It just sleeps for the given amount of time. So there may be some detections that or some scans, maybe some endpoint solutions do a memory scan for every process that is started. And if some solutions do so, or some solutions definitely do so, this can also be used for sandbox evasion, for example. If a sandbox ends its check after, for example, 60 seconds, then you can specify sleep 75, and everything will happen after sleeping 75 seconds. Sorry. As I said before, I'm not using any Windows API here to sleep, but instead it's calculating. So it doesn't look for an endpoint solution, or an endpoint solution cannot monitor this, but it's calculating for this time. And yeah, if we can use this just one time here as an example for calculator, we'll specify sleep 5. Execute our loader exe, and then you will see it's sleeping for around about 5 seconds. It's not exactly 5 seconds, and after 5 seconds the whole procedure is done again. So patching AMSI, patching ETUE, and executing the shellcode itself. Yeah, then you have the possibility to inject, also for shellcode. This is only for shellcode in the moment, to inject shellcode into a remote process. You can do this with --remote inject. By default, if you don't specify a process name, then this will generate or create a new process, notepad process, a hidden notepad process, and will inject into this new notepad process. If you want to inject into some other processes, obviously you have to know if your target process is 64-bit or 32-bit, because if you want to inject 64-bit shellcode, you need to specify in 64-bit remote process, just as basic information. If you want to use a remote process, I did specify here, for example, Teams, Internet Explorer, and or Edge. We can try we can try Edge here in this case, for example. Should be 64-bit, I hope so. If you specify multiple remote process names, then because maybe you don't know the target environment for sure, and you want your shellcode to definitely being executed, but you don't know which processes are running, maybe, so if you're using that for pitching whatever, then you can specify multiple processes, and each one will get looked up, and the first process name that is found, the injection will take place there. So if we specify Edge now in this case, it should inject our calculator shellcode into Edge. Okay, looks like maybe it's called different. It's definitely called different. No edge process running. What the fuck? I should change my README if the process name is not really MS Edge. It's just MS Edge. Let's try. That did work, but calculator didn't spawn. Most likely because if your remote process has some protections in place, like ASLR or whatever memory protections, then your shellcode cannot get executed that easily. I think I know that TeamViewer doesn't have such protections. It's a service. It's maybe running a system, so this won't work. Not from a low privileged session. What else can we? Where else can we just inject for the moment to test this? Smart screen. A smart screen. I know what to do. We can also inject into PowerShell. I have PowerShell open. I think PowerShell should work. Yeah, PowerShell did work. So injecting into PowerShell did work. Process was found. PID is 2272, which is correct, and it was injected into this process. That's about remote injection. Nope, it's 2 more parameters. You also have the possibility to, that's only for remote process. Oh, forgotten detection. That's not the time from now. That's not our time at the moment. 201. I don't think that it did detect, at least there's no message for this time frame here. Maybe there was an older message, I don't know. You can also patch AMSI in the remote process or patch ETV in the remote process, because that's an, PowerShell was also killed. So it seems like Defender did a memory scan for the PowerShell process and found the MSF shellcode in the PowerShell process and killed the process afterwards. So for Defender, we can see that in this case, it did detect the shellcode because it did analyze the remote process. Maybe, and that's just troubleshooting. This will not get detected if you specify this Whispers, for example, or Hellsgate. So you have to figure out on your own which technique to use. It's the operator's choice from my point of view, which choice to use. And some techniques will work for one endpoint protection solution and others will work for other endpoint protection solutions. And it's always about fiddling around with these techniques and functions and find the one that's perfectly fine for you. So if we want to patch AMSI, for example, in the remote process, we can do that just for fun. I'm not using calculator here again. I'm using seatbelt, which makes absolutely no sense. But just to show you that patching AMSI works, So in this case, AMSI is enabled. It will, in this case now, inject seatbelt into the remote process and try to execute it. That makes no sense. It will not work. But oh, and I didn't specify. I specified remote patch AMSI, but it will still patch AMSI before. So if that works, we will get an error message here. Maybe the process is not killed because a seatbelt is not found there. But AMSI should be disabled afterwards. And another cool thing that I implemented here is loading the library if it doesn't exist. Some remote processes might not have AMSI loaded already, so AMSI DLL is not loaded there, or NTDLL is not loaded there. If that's the case, then my Packer will load these binaries into the remote process. So, as I said, patching AMSI in the remote process didn't work. Okay, it was still killed. So AMSI seems to be also, and I cannot show it now. Remote process was killed, unfortunately. One more try. No, Notepad makes no sense. I will make one more try, but it's I don't want to make too much troubleshooting here and now because it's, as I said, choice of the operator from my point of view on which technique to use and on how to find the correct thing for you. Maybe Hellsgate is not detected in this case because it was not detected like 20 minutes ago. Calculator spawned. PowerShell process is not killed. Looks like Defender is not good. AMSI scan buffer at detecting Hellsgate. Oh, now it was found. It just took a little bit. Okay. So, but this is also a thing you should have in mind. I cannot avoid with any Packer. Any Packer cannot avoid memory scans because when the shellcode or assembly or portable executable is loaded into memory or from memory, it's in clear text. So it's still, if you're using a Packer, it's still up to you to obfuscate any portable executable or assembly before packing it. Yeah, I will put this in the YouTube channel. I will do that. So it's up to you to obfuscate that. I don't think, and I asked many people, there are no shellcode obfuscators at the moment, no public ones at least. So if you want to, if you are using shellcode for a C2 framework, for example, then memory encryption, encrypting the heap and stack for the sleep delay is the only thing you can do in the moment to, at least from my knowledge, to avoid these detections. So that the memory has to be encrypted on sleep time. But if you're using, for example, if you're using Mimikatz, generate shellcode from it via Donut and load it in the current process, you cannot encrypt memory because Mimikatz will not work anymore. So for those situations, you have to change the source code. Or if you're using shellcode, I know there's a technique, pick your own malware. You can use C code and generate it so that it's only a text section. So you should be able to generate your own shellcode with this technique, for example, but you have to know how to code in C or C++. And if you do that, your shellcode may not get detected in memory because it's a custom signature. You did write that on your own. Then it cannot get detected. Yeah, that's it for remote injection. What else can I show you? Minus unhook. Unhooks and TDLL before doing anything else. So it's as I said it many times now. It's up to you on whether you want to unhook or not in the current process. This is done for the loader process. It's done before everything else, but after sleep, for example. And if you want to avoid some detections from using anti-DLL functions, then you can use unhook. And it will use a fresh anti-DLL from disk to replace, I think it's the text section of the anti-DLL in memory, so that all hooked functions are not hooked anymore afterwards. Will not show that because I don't want to make a too long video here in this case, and that's just operator's choice. Reflective is an interesting one from my point of view, because you can, let's try this again, also load Nim binaries from memory if you do so. And that's the only purpose. Reflective just adds some compiler parameters so that your Nim binary is loadable from memory. And that's cool because you could, for example, load your Nim binary in PowerShell, or you can load it from some C# assembly, whatever, with PE reflection technique. So PE load is needed, reflective is needed, and if you do that, I have to think now about this. May also get flagged. We'll see, because I'm using Mimicuts, obviously. As I said, you should, if you're using Mimicuts, you should obfuscate the source. Invoke reflective PE in wiki. Always going into this. Just cannot remember some functions. Invoke reflective PE injection. So this version is a little bit newer, at least. We need to patch AMSI to load reflective PE injection. Let's see if this is detected at the moment. Nope, it's not. So AMSI is bypassed. We can load this. It's called invoke PeInject. The function name, we can load our Nim binary now into memory by doing this, for example. If you're embedding it in a PowerShell script, you should obviously, for example, encrypt it or base64 encode it and decode it on runtime to make this work. I'm now grabbing it from disk to put it into memory, but minus PE bytes are in this case ASD. So this should now also work, and it works. So our Nim binary, which decrypts Mimikatz on runtime in memory, is now loaded in the PowerShell process from memory. That's cool. So you can use --reflective to do that. And if you do that, then you can do reflective PE injection or run PE technique for the corresponding Nim binary. And that's also good, for example, if you, in this case, it's not flagged. Normally, this is flagged by Defender because Defender doesn't memory scan and scans the memory for Mimikatz. I don't know why this didn't happen here. But most likely because the process is not that new. It already existed for some minutes, and after some minutes no memory scan is done because most malware executes directly. I don't know, but this is a cool technique to load the Nim binaries from memory. Okay, that's the reflective parameter, so you don't need that if you don't want to load it from memory. You can use Obfuscate to make use of, I don't think I have it in the path right now, Denim. Denim is public GitHub repository from Moloch, which, oh, this is not flagged. No, it's not flagged. I don't know, to be honest, how much time this takes to install. But Denim is capable of, or is a POC for using LLVM obfuscation for Nim. So you can use LLVM, obfuscator LLVM for your Nim code, and that will generate an executable which is completely different from the original executable. You have to read about LLVM and obfuscator LLVM to get an overview of what it's doing. But this is more or less a completely random executable anymore. There's, I would say, no choice or no option for an antivirus vendor to detect the signature on disk. That's also the signature on disk again, because our payload is still decrypted on runtime and is still clear text afterwards. So this is just an option to add, or if the loader is still detected somewhere, somehow, for some reason, then you can use --obfuscate, and it will use LLVM, and most likely your executable will not get detected afterwards anymore, because LLVM has really good randomization and makes many changes, so that signature-based detections really cannot happen anymore for your binary. To set up Denim, you have to put Denim into your current working directory and use Denim setup. Then it will download a dedicated MinGW version, which is also capable of CLang and LLVM. It will extract that, put it somewhere in app data, and afterwards it downloads Obfuscator LLVM. I think it's version 9.01 or something like that. And that will take at least some time, so I can take a look at more functions for the moment. Oops. Yeah, I also did include some sandbox checks. If you want to use sandbox checks or sandbox evasion in your pack binary, you have different choices. You can, for example, only execute, or the payload is only executed if the target is domain joined. So if some non-domain joined system executes your payload, then it will never get decrypted, it will never get executed, and so it cannot be analyzed. Most sandboxes do not have a domain join, so this is a really easy option to avoid sandboxes, for example. If you know your target domain, if you know your don't know, pentest, red teaming, whatever, internal target domain, you can use -- sandbox and domain, and then you also have to specify the domain name as a second parameter, and only if the target domain on the target system is example.com in this case, then your payload will get executed. In any other domain, it will not get executed. There's also a disk space check. You can also use multiple. You can say the target domain is has to be example.com, and you also want to check, for example, for disk space. This will, in the default configuration, check if the main disk has at least 200 gigabytes of space. It's easy to change this value in the source code. So if you want to check for or only execute on systems with, for example, 500 or more or 50, whatever, then you can just change this one value in the source code. And any system that has, for example, 50 or 100, if that's the case, then it won't get executed. Memory space is the same, but just for the memory space. So the default value here is 4 gigabytes, and if it's more than 4 gigabytes or equal, then the payload will get executed. I don't think that I have to show this here because it should be obvious from my point of view. This is just how to do it. -- sandbox, then the checks you want to add. If you also want to check memory space, then you can do it like this. And then you have these 3 checks. Pump is another feature to, yeah, it's not to avoid signatures, but it can be used to avoid so-called, from the vendors, so-called machine learning components. I added this tweet here as a reference because this was more or less the thing that I saw which lead to me building this into the Packer. He found out that CrowdStrike looks for the total entropy in an executable and will block it if the entropy level is above some threshold. And if you add just English words in your binary, then the total entropy will decrease, and if it's over, or yeah, if it's less than the threshold that is specified by the vendor, then it will still get executed. I had this for some other EDR solutions in the past, that they didn't delete the file. They also didn't do anything else, but they just said denied. So I wanted to execute it, and they just said denied all the time. I think that this is this was also a detection with the same source. So it was also just checking the entropy, and if nothing with a better nothing normal is in this executable, if you only see some strange things, then it will get blocked. And by using -- pump, the Packer will add multiple thousand English random words from a dictionary into the binary so that those detections can be avoided. I also added this increases the compile time, but that's not a problem at all. I think it's about 1 to 3 minutes to compile it because of these many words, but it still works the same. If you want to use pump with not with English words, but for example with strings that occur in well-known binaries, then you can use reputation as argument for it. And I did take out the strings of many default Windows executables like Cortana, for example. I also took the strings out of Discord executable, out of Chrome, and of many other binaries, and I put them into a word list, and this word list is now in the very end used by my packer, and also thousands of words from these legit binaries are added to the executable, so that the entropy gets better. Yeah, that's behind this feature. Can do this one time. Oh, English. Oh, stone scan calculator. Yeah, now it takes some more time because of these many words. The executable also gets bigger. Some detections come indeed from the file size. I've had this situation from time to time that, for example, executables with under 1 megabyte were detected, but others which were just bigger were not. And here the file size, okay, it's still not that big. If you also add English words in this case, it will get bigger again. I also think it's bigger than 1 megabyte then. But I also had situations where small executables were blocked and bigger ones were not. In this case, it's not that big. It's just nearly 400 kilobyte with words from several binaries, and the calculator was just 1 kilobyte. So yeah, this is nearly nothing. Okay, that about pumping. I think Denim is now installed and should now work. I hope so. Maybe I have to sign out and sign in again for this to work. That's the parameter minus obfuscate. We will see if this works now, because either I get an error or I don't. But I think I have to sign out and sign in again because of the new compiler version and its path. But it's taking a while, so this looks like I don't have to do it, and it's compiling at the moment. So because I talked about something else now, obfuscate is LLVM obfuscation in the very end. And this will definitely increase the file size a lot. We had like 400 kilobytes with pumping, and as you will see, this executable will get much bigger, but it also takes a longer time to compile just because of LLVM. I also have to say that this also only works for Windows. This only works if you use the Packer from the Windows system, because Denim also only works for Windows. And I'm not thinking about, or I do not plan to make this also work on Unix. Moloch also doesn't want to do this. I think it's somewhere in the issues. So this feature will not work on any other operating system, just for your information. Now our loader executable is 10 megabytes. So the payload is just 1 kilobyte. The resulting binary with LLVM obfuscation is 10 megabytes. But this is detecting this with a static signature detection is, I think it's not possible. So with this you will definitely avoid signature-based detections, or you should. The only thing that you additionally have to care about is maybe this here, entropy. If you use LLVM, maybe your entropy gets bad again. That could happen. I don't know it for sure, but just to verify that this also works, still works, calculator spawned. So our 10 MB executable also does the same thing, but is obfuscated much better. Yeah, not many more features left. It's just about self-delete. That is the POC that was initially found by Jonas Lück, or the technique found by Jonas Lück to delete the executable on after runtime. So if I specify this, exactly this technique is used in the very end, a Nim version of it. So our process deletes itself after execution. So if you're executing the payload anywhere, or if a victim executes the payload, then the file on disk itself cannot be analyzed afterwards, because it just doesn't exist anymore. So we have our loader exe here now, and if I execute it, you will see that it will disappear. Now it disappeared. It just deletes itself after execution. So you can more or less clean up by doing that if you don't have access to the system or whatever. One more thing to mention, with every option that you enable here, it's possible that your target environment can still flag the payload. For example, self-delete can, and some vendors just detect it. If you use self-delete, it's possible that your payload will never get executed because the vendor did detect exactly this technique, and it's a behavior-based detection. And the Packer cannot avoid behavior-based detections. I would have to port this Windows API functions that I used here to syscalls, and I just didn't have the time yet to even take a look on which syscalls need to be used here. So I didn't port this to syscalls. It's in the moment using dynamic invoke, so it's taking the functions from the process's own memory, from the process environment block. It's parsing them from there. That's maybe something that's not detected by some vendors anymore, but I cannot guarantee this. And so it's, as I said before, your choice on how on which functions to choose. If you use self-delete, it may be possible that the packed executable gets detected afterwards. But the same also applies for all other things. Maybe this whispers will get detected, maybe Hellsgate will get detected. Maybe, I don't know. There's also a PeInject. I didn't show that here. If you have donut in the current path, then you can also execute portable executables in the current process or remote process by building shellcode out of the executable with donut. Can you make a simple short case? I think it's also embedded here now. Yeah, it's also embedded. That's easy to show. Yeah, so that's the next thing I'm going to show. We can use mimicards, for example. We can say PeInject instead of PeLoad. PeLoad is my custom run PE implementation in Nim, and PeInject is using donut in the background to generate shellcode out of the executable. I'm also not using the default release version of donut here, but instead I'm using a version that was modified by Santiago P, the guy who released NanoDump. And he also made several changes to donut that are really cool. So I'm not using the default version, but I'm using his fork. This fork here is in my repository, and this has several more cool features like, oh, it was also merged. It looks like it was also merged. I don't know, not for sure. No, there's another, I'm using the syscalls branch. I'm not using the main branch, but the syscalls branch, and this has uses syscalls for AMSI and event tracing for Windows patching. The APIs are resolved in a different way. There's also relocation support. Some binaries do not have a relocation section, and the normal donut version fails when they don't have a relocation section. With this version, you can still make shellcode out of an executable, even if it doesn't have a relocation section. So all in all, this version is better than the default donut version, and I'm using this one. Yeah, it generates some shellcode out of our mimicards. It also overrides the PE headers. In this case, I don't know if the normal donut version does that. I think the release build at least doesn't do it. And overwriting the PE headers can also lead to avoiding memory scans. And here, as you can see, we can also execute our packed mimicards executable, pass arguments to it, and yeah, that's using donut in the background here and not run PE. So not much left. Minus debug is just for debugging purposes. You will see more output. I will see more output to troubleshoot bugs. Or you can report more output to me so that I can fix bugs with a better overview what happened in the background. Obfuscate functions is another parameter that just uses call obfuscator in the very end so it's a third-party tool as well to obfuscate specific Windows APIs. As I mentioned in my Nim invoke, which I released 3 days ago, every Nim binary by default expose the same functions. In every Nim binary, these functions here are exposed. It's about kernel 32 functions, and it's about functions from this DLL. And all Nim binaries have these exposed, and you cannot avoid this because it's just how Nim works. And with call obfuscator, I did build a custom configuration file for it. The default configuration file, config ini, obfuscates all user32 functions and replaces them with the ordinal 1600, and it takes all kernel 32 functions and replaces them with sleep. I did replace that. I made a custom configuration which applies to the most suspicious functions which are exported in Nim binaries. So, for example, I'm obfuscating virtual alloc, virtual protect, virtual free, load library R, get process, get proc address, where is it? Get proc address. These functions and some more are replaced with call obfuscator. That's how I understood it. It's little shellcode that looks like it's a DLL, but you have to take a look at this repository here. It's more or less a jump to the real API function on runtime, and but the binary itself only exposes other functions. So if you use that -- obfuscate functions, it will not look like this, but instead I replaced the most suspicious functions that are included here with less suspicious functions. So if someone analyzes them, they will not find these, but instead they will find other functions from the same DLL. Yeah, that's what's behind obfuscate functions. This is also only possible from a Windows operating system, because yeah, this is just an you can use Wine or whatever to make it possible to use that on Linux, but yeah, try to compile this on a Unix system. It's not that easy, so I'm just giving Windows OS support here. Yeah, 32-bit support. I have to just, that's not fully functional at the moment. -- LLVM adds compiler flags for LLVM obfuscation. That's an alternative for Denim, which is also which can also be used from a Linux system. I hope I find that now, because I just stole it. I just stole these flags from IC Guider. Yeah. And he has a description here also on how to configure obfuscator LLVM for a Linux system. If you do this, and if you also specify this flag, and if you did this here the right way, yeah, that's up to you to configure this, then you can also use LLVM obfuscation from Unix systems. That's the alternative to Denim. So now I just didn't talk about, I think, hide, SGN, and replace. Hide is simple. It just hides the console output. So that makes no sense for seatbelt, but in this case it's just to show you that we get no output anymore. If you, for example, pack a command and control stager, and if you put this into the autorun directory of some target system, then the CMD will spawn every time when the stager is executed. So it's not happening in the background, it's not hidden, and the victim will always see the process and will see the process output. And that makes absolutely no sense for an command and control stager. So if you're using a command and control stager, you should always use --hide, so that it's executed, but it's executed in the background and there is no output and no CMD window will pop up. That's this functionality. SGN is using SGN in the background to, so another third-party tool to also encode shellcode and to also lower the entropy of the shellcode. Maybe this will also lead to less detections for in-memory scanners, because the shellcode is just obfuscated with one more layer. Some antivirus vendors or EDR vendors try to find the key which is used for encryption in a binary and to decrypt it even before it's executed. I found that out because I uploaded some samples to VirusTotal using sleep with a value higher than 80, and on VirusTotal the systems usually don't scan longer than, I think it's 70 seconds or something like that, and after 70 seconds you get all the output. So the payload itself will have never get executed in my testings, but some vendors still detected the shellcode, and they even detected it as correct. So for example, they did detect MSF shellcode as MSF shellcode, or a beacon as a beacon. And that must have been a detection in which the vendors search for the key in the binary, and they just try, if you have a base 64 blob, for example, in your binary, they try to use each string in your binary to decrypt this base 64 blob. And if they find the shellcode, then they say they detect it. And this is one more layer that makes it harder for a vendor to find the real shellcode in the executable when just analyzing it. It's still a different thing to memory scan, because in a memory scan this is still clear text in the very end. Okay, I got one error here, but I don't know why, but the shellcode was still executed. Cannot tell you what this error is about at the moment, to be honest. But I didn't have it any time before. Maybe it's because output test. Yeah, and in the very end, it's just one more thing left to explain. And that's the replace function. I will make one example to show you. Is this the right one? I think it should be. Now we're not getting this error anymore. Something was wrong here, but now it's. If you're using, for example, PeInject, you can analyze the strings in an executable. And I don't want to showcase this here and now, because this will be public. So if I use the replace parameter, many Nim binary specific indicators of compromise or Nim binary specific strings will get replaced in the resulting binary. So, for example, if you have a Nim binary, I think that's also somewhere here. That's the strings section in PE Studio. And if you have some hello world function, for example, it will be about 3,500 strings, and many of them are Nim specific. It's about Nim error messages, it's about Nim library names which were used to generate this. For example, system.nim, systemio.nim, and the Nim files which you were using in the background, they are all embedded as strings in the binary. And what I'm doing with this feature here is I did generate a word list, another one which contains many Nim specific strings, and all these strings are replaced after compilation so that they don't appear in the binary anymore. So if anyone is searching for Nim in a binary and I don't know, I saw Jara rules using that. For example, those Jara rules will not apply if you use replace. So replace, I can really recommend you to use that, because everything that makes your binary look like it's a Nim binary will get replaced with it. Another cool thing or fun fact or whatever is that all other strings, if you see these strings here, for example, this is more or less an echo statement, and in a normal binary you would see this because it's everything that is console output can be seen in a binary as string. All these things are also encrypted with a custom value, so it's encrypted different every time you compile a binary. With the packer, it looks different because these strings will get encrypted with a different value each time. And all these values cannot be seen in the binary anymore because they are encrypted. And they are just decrypted to make the output here for the moment. I didn't analyze, to be honest, if they are still unencrypted after they are echoed out. I don't know that. I would need to check it. But they are indeed definitely encrypted for the binary itself. So if you analyze the binary, you will not see any of these things here. Yeah. That's about the packer, about the usage, about its current functionality. Yeah. Some questions left from any one of you here who joined. Going through the chat for a moment. If you don't have any further questions, I would say I will stop this now here. I will upload it on YouTube afterwards so that you can always take a look or look things up. And that's it for today. Yeah, the word list pumping feature is indeed a cool thing. So then, no more questions. I'll say bye-bye and have a nice Saturday.